in order to be able to name any molecule in organic chemistry, you have to be able to identify the parent chain, also known as the longest chain of carbon. So let's use the example that we have drawn here to talk about how to identify your parent chain or your longest chain of carbon. When you have a line structure, first thing, go ahead and use a dot to identify all of your carbons that you have in the molecule. If you don't remember anything about line, we go back in the channel and you'll find information on line structures. So these are all the carbons. Now the idea is to find your longest chain of carbon. So obviously what you want to do, your obvious instinct is going to be, okay, let me just connect all these dots. Now, here's the thing. When you connect the dots, it has to be what we call a smooth chain. And what we mean by a smooth chain, if you are connecting these dots and you make any kind of shape, whether it's a triangle or anything apart should look like a square, you do not have a long chain. So let's look at what I mean by that. Let's connect these dots. Let's go connect this dot to this dot, this one to this one, because I'm trying to find the longest chain, then go from here to the next one. Anytime you make a shape, this is a triangle, you do not have a long chain, so you can stop right there. That's not your longest chain at all, right? So let's get rid of this line right here. That's not your long chain because we made a triangle. Forget that, move on, because that's not it. Let's keep going. Let's try something else. Let's get this pen back. So let's connect. Let me use another color for this. Let's connect this carbon to this carbon to this carbon, this one to this one, then from here to here, here to here to here. This is beautiful, right? We did not make a triangle, okay? But let's count how many carbons we have. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons for red. Also remember, when you're trying to find your longest chain of carbons or your parent chain, the goal is not to connect all the carbons, right? It's to find that smooth chain, which this red, everything in red here is showing a smooth chain. I didn't make any shapes, okay? But the question now is, in this big structure that I have here, is that the longest chain? Is that the chain? Is 8 carbons my longest chain? That's the question you need to answer. So let's try something else. What if we connect this carbon to this carbon to this carbon to this carbon? This one, we go here, we go here, we go here, here, here. We didn't make any shapes. I didn't make any triangle. So let's count how many carbons we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So blue, 10 carbons. And that is your longest chain of carbons. If you want, we could try, let's try another possibility. So if we go here and I connect this carbon to this one, this one, this one, this one, this one. That's also a chain of carbons that I did not make a shape, but is it the longest chain of carbons? 1, 2, 3, 4, 5, 6. 6 carbons, so it's not. So blue is your longest chain of carbons. Now I need to highlight some, this is extremely important. The blue, sorry, is your longest chain of carbon. Any carbons that is not highlighted in blue is what we call substituents, right? So this is a substituent, this is a substituent, this is a substituent, this is a substituent, right? Because blue is our longest chain. That's the longest chain of carbons, right? So any carbon that is not blue, and we like to say it's hanging off of um, the blue the blue chain of carbons, anything that is not a part of this, is what we call a substituent or a branch group. And it's called a branch group because you want to imagine that this blue part here is the trunk of your tree, right? Or the stem area of your tree, and everything else hanging off of it is considered branches, right? It's not a part of the stem, right? So that's why substituent is also known as branch group. But remember, once you find your longest chain of carbons, right, then anything that is not a part of your long chain but is bonded to the chain are considered to be substituents. We learn how to name those in a second, but this is what you do for your line angle. Just remember, one of the most important things here is once you make a shape, that is not your longest chain. So for example, if we had done here to here, to here, to here, to here, here, and then I went here and did this. Whatever shape this is, once it's not that, you notice how the blue line is smooth? It has to be that smooth movement. Anything looking like a shape, you can just quit. It's not your longest chain. So this right here would tell you that you don't have your longest chain. Key to being able to identify your longest chain in any molecule, you have to practice. You have to practice